Differentiating by using the rules. Here are the rules that you're going to use. This is now if the question does not say use the from first, find the derivative from first principle. If it doesn't specify from first principles, then you can just use the rules. You'll see this is much shorter, and differentiate by them. Right. Now the first rule that you work with on school level is just ax to the power of n as a function. The derivative will be nax to the power of n minus 1. Now it looks crazy, but what you do if you have your function, if you look at that, you take this exponent, you go multiply it in front, right? So there it is now. And then from the exponent, you subtract 1. So it's two things you do. Multiply the exponent in front and subtract 1 from the exponent. Right, that's if it looks like this. If it looks like this, which is just a constant, any constant number, I have a function in terms of x, which means anything that's not x will be seen as a constant. And then the derivative of that will simply be 0. Right, the derivative of a constant is 0. Just keep that in mind also. Okay, and then I said in my notes, but unfortunately, the catch is they're not going to just give you equations that looks exactly like this. They're going to give you maybe something with roots in, or something with a fraction, or something with brackets in, and this is how you work with that. Then you must just first manipulate this equation or that equation so that it looks like these things, so that you can find the derivative with the rules. So keep in mind, remember that that roots I can write as an exponent. A root is just the denominator of a fraction exponent. So my exponent stays my exponent, and the root just goes under the line in the exponent. Then under the line, the whole base with exponent under the line, I can take to the top by just making the exponent negative, and if you have brackets, just multiply them out. Right, so I'm going to start with this one, which these brackets, so I'm going to multiply them out. And please don't just square both these terms. You must actually go write the bracket twice and multiply this out. So I've got 4 times 4 is 16, minus 8x minus 8x minus 16x, and I trust that you can multiply out brackets by this time. And minus 2x is plus 4x squared, if I multiply that out. Right. And also, please don't write dy dx here, or f accent x, the derivative, because this is still my function that I'm just manipulating to look more like the form that I'm working with from my rules. So I'm first just manipulating the function. This is still equal to that. Right, and now after I've done that, then I can find the derivative, and only then do I write either this or f accent x or whatever. So then I'm going to take term by term. So the first term is a constant, so the derivative of that will just be 0. The second term looks like this, where my a is negative 16 and my n is 1. Can you see? Right? So I'm just going to multiply the 1 in front. So 1 times negative 16 is still negative 16. And from the 1 exponent, I'm going to subtract 1. Now 1 minus 1 is 0. So that's then x to the power of 0. Okay, and then this one, I'm going to multiply the 2 in front. So 2 times 4 is 8. And then from the 2, I'm going to subtract 1. So then my exponent becomes 1, which you don't need to write. Okay, so then this is 0. I don't need to write it. Minus 16. X to the power of 0. Anything to the power of 0 is 1. So that's just times 1, which you don't need to write. And then plus 8x. Right, so that's the derivative using the rules of that first equation. Let's look at the second one. So I see brackets. I'm going to multiply them out. So root x times root x is x. And root x times negative a is negative a root x. and then that a must still stand there. Right, now please remember this is a function in terms of x, and I'm going to find the derivative in terms of x. So these a's in the function counts as constants, because my function is in terms of x. Basically anything that's not x is just numbers or constants. So even if it's a, you can see it as a constant, right? Okay, then the second thing is I have the root there. So I'm just going to rewrite that root as this is x to the power of 1, and then the root is a second root, so the root goes under the line in the fraction. So this is x to the power of a half plus a. And now I can start finding the derivative using my rules. This is in this form where my a is 1 and my exponent is 1. So I'm going to multiply 1 times 1, which is 1, x to the power of 0 if I subtract 1 from that. And then here I'm going to multiply that half in front, so I've got negative a half a, x to the power of a half minus 1, which is minus a half. And then the a is a constant, so that will just be 0. Right, now let's just simplify this a little bit. Anything to the power of 0 is 1 minus a half a. The negative makes it go under the line, x to the power of a half, but I also know that x to the power of a half is a root a half. And then the plus 0 can fall away. And just to also combine this whole fraction, the a is actually a over 1. Just to combine this whole fraction, it's just cleaner to write it as a over 2 root x. Although I'm sure if you write it like that, it's not necessarily the end of the world. All right, so that is differentiation using the rules. I'm going to do some more videos with this so that you can get a lot of practice in. Once you start feeling comfortable with this work, please stop the video, pause the video, and try the questions on your own, and then play and see if you can do it on your own and if you are correct.